Okay, hello, here we are. Hopefully this works. I may need to restart my computer before I begin. That's a lot of drop frames. It'll take a few seconds. Okay, we're back. All right, looks good. So, haven't been on for some time. Had Thanksgiving and some other things going on. And my frame rate is terrible. That's very disappointing. Forgive me. Forgive me. I've not been able to figure out exactly why my frame rate has been so bad lately. It's been just going on and off consistently for quite a while. I don't know what it is. I don't want to take the time to spend that much time trying to figure it out either, because it's just, I'd have to really go into, I don't even know where to begin with that. I don't want to focus on it. Anyway, sorry, it's like a whole full minute of me just complaining about my internet connection. All right, so let me begin. So it's going to be maximum subarray sum with, let me just make sure the audio is working. Yeah, so it's going to be maximum subarray sum with one deletion, and the chat is out, and I can go ahead and continue here. So I think I got everything. Yes. Sorry, I'm just thinking before I think I can do this. Okay, very good. All right, let's see how far I get with this question. Yeah, I think the plan is going to be to I'm going to try to get to 1,000 questions, and then I'm going to take a break for a while. I think I'm going to go work on other things. As you can tell, I'm like a little bit, you probably can tell just from today, that like I'm kind of overwhelmed with problems, and I cannot actually address all of the things I need to address, and it's driving me kind of insane. It's driving me insane. So I need to like reassess and readjust, that kind of thing, figure out what I'm going to do. Anyway, maximum subarray sum with one deletion. Given an array of integers, return the maximum sum for a non-empty subarray, contiguous elements with at most one element deletion. In other words, you want to choose a subarray and optionally delete one element from it so that there is at least one element left, and the sum of the remaining elements is maximum possible. Note that the subarray needs to be non-empty after deleting one element. Okay. At most one element deletion. Okay, so I don't have to delete an element, but if I were able to delete an element. So it's 100,000, the numbers, so I cannot do, excuse me, there's a quadratic time algorithm I could do where I basically just delete one element at a time. Actually, it would be more like cubic, but deleting one, well, no, it wouldn't be, it would be quadratic. Yeah, deleting one element at a time, or just setting an element to 0 and running Cadane's algorithm. Thinking I might be able to run a variant of Cadane's that uses some dynamic programming. That could be interesting. That should be linear time. Thinking about that, actually, that'd be kind of cool. Basically just a DP algorithm. I think so, yeah, actually, I think I might be able to do that. I can't see it immediately, but that may be possible. Some other ideas would be like, while I'm running Cadane's, I could always just set whatever number I'm operating on to 0, and check that as well. The problem with that is, excuse me, yeah, I think I should probably use a dynamic programming solution, actually. I was trying to think, like, you could do, like, when you're running Cadane's, you could set the element to 0 or not. But the problem is that if you set it to 0, you have to keep going the rest of the algorithm with that 0 value, as well as not setting it to 0, so to speak. And it's not always better to set it to 0, which is confusing. Yeah, I think you gotta use, I think I need to use DP to do it. Not just a modified version of Cadence. Let me think here. Excuse me. Okay, I think I can use a modified version of Cadence. All I really need to keep track of is just I can use DP. The idea would be the maximum subarray sum up to this. So what I'm going to calculate at each point is the maximum subarray sum that includes that point, right? And at each point, and then I'm going to take the maximum of those maximums. And I also can calculate the maximum subarray sum that includes that point that has used the deletion and set the value to 0, right? Subarray needs to be non-empty after deleting one element. I was gonna say there's a, if it's all negative, then you just have to pick the smallest element, I think. The reason that's just kind of like an edge case. Could handle that as an edge case. Because yeah, if it's all negative, then you'd want to just pick the smallest negative number and not grab any more numbers than that, because it'll just make it more negative, right? And you can't delete if this other algorithm, if I ran it on negative numbers where I just set the number to 0, you would get 0 instead of the correct amount. So I could just handle that separately. How am I doing on time? Let me just make sure I have the right idea here. So, yeah. Excuse me. There's no real benefit though to. Well, yeah. There are two options. The maximum subarray sum at that point that doesn't use a deletion, and the maximum subarray sum that does use a deletion. And there might be a maximum subarray sum up to that point that already used the deletion when you get there. And then there's a maximum subarray sum that hasn't used a deletion, and both of those have different options. The one that hasn't used a deletion yet, all you can do is sort of the normal Cadence approach, where you consider adding either you start anew at this point, or you add what you've already calculated to this point, and that becomes the new value. Whereas the other option, there's two possibilities, right? If you're at that point and you're considering you haven't used a value yet, you could either not use the value and calculate that. So I guess there's 3 numbers you're calculating. So there's those 2 numbers. Not use the value yet, and get that maximum subarray sum up to that point, and then the other number is set this one to 0, and then check that against the other possibility of having used it previously. Yeah, something like that. So the 2 things that I'm going to keep track of, instead of 1 number, it's going to be 2 numbers that are going to be well, it's really 2 numbers normally, but 2 numbers with regard to this particular calculation, I guess, not the idea is that at each step you also just take the maximum of those other two numbers, and that's eventually what you return. But putting that aside for a moment, just figuring out at each step, based off the previous steps, what the maximum subarray sum that includes this element, what that would be if I had used a deletion and if I didn't use a deletion up to this point. Yes. So interesting. Okay. Let's see. So it might look like something like it might look like the following. I don't know if it's correct. I think it's right, but int. We'll say with deletion is 0, and without 0, const int x and array, and then we're going to have result and return result. Excuse me. It's going to be with deletion. Try to make it as large as possible, right? Without deletion. And then result is going to be the maximum of those two. Okay. So without deletion, normally the way this works is I'm going to say either it's going to be start again at just that value alone, or add this value to the previous amount that I got, right? So just before it is an array that ends at that point, and there's some amount associated with that, which is the without deletion amount. I can either add that to x or just start x alone, right? The other option is with deletion. It's almost the same thing, because with deletion means I've already used the deletion, and now I'm going to sort of start. I'm going to sort of continue on in that way. I've deleted something from the array. The third option here is without deletion, I could now update the with deletion where I use 0 for without deletion. Right? In other words, this can be updated. This can be updated where the without deletion, I could just take x to be 0, perform the same calculation as the with deletion, same calculation of the without deletion with a 0 now, which is this part, right? And then also check that against the current with deletion amount. So it could be each of these, right? Could be each of these. And that would give me the best possible subarray that has a deletion at that point. And then the best out of those will give me the results. So something like this, I think, will do the trick. There's also one more detail where it's like there's like a C++ version of all of, yeah, let's use one of these. All of, and it's going to be, what's the signature? Predicate. Yeah, we'll do all of, okay. If standard all of return min element array begin, array end, If all of array begin, array end, and the predicate is going to be constant x is less than 0. Yeah. Then I just return the minimum element. So I think something like this is what I want. Something along these lines. How am I doing on time? 15 minutes. Okay. Compile error. Deletion without. Oh, yeah. Whoops. Maybe I should have named that without deletion. I went through all the trouble. I typed it all out down here, but I made it shorter here so it wouldn't be so difficult. So much effort. Wrong. No. No. Really. This could go all the way to 4. Okay, so this doesn't work the way that I think it works. That sucks. That would be easier if it was right. Definitely would have been easier if it was right. Yeah, I kind of thought like maybe it's not quite right. Something's not quite right. Yeah, so okay. So with deletions, let's just walk through each of these. So with deletion 1, we get result 1. We get with deletion is oh, this is actually yeah, I guess this is fine. The with deletion just assumes that I deleted something already. It's similar to the without. It's like the same calculation here. Anyway, so okay, so we start with 1 for both, and then the next iteration, we say -2, and the result is 1. So we have -2 and with deletion plus -2, which would be 1 plus -2 is -1, so that becomes either a -1 or -2 should be -1. This one should be also -1, same thing, and then this becomes so this is -1, this is -1. The maximum of this is 0. This should be 0 here. Oh. Oh no. Oh. I think this is supposed to happen before the other calculations. Oh no. Let's do it this way. Apply deletion. Yeah, applying the deletion, I should get 1 here, right? So the with deletion, without deletion, and then I update with deletion. That's kind of confusing. Maybe more operations than is necessary. I think I see what's going on there. Oh no, now it's the other one's wrong. Oh no. I don't think the logic is right. I think it's more complicated than I'm letting on to be. But no, but now this does an infinite number of deletions, right? So the problem with this is I can't apply the deletion to the without. Yeah. I think that's part of the problem. Okay, there we go. Let me generate some test cases. So this is a little confusing. Yeah, before updating without, I need to apply the deletion calculation. And then the with deletion, normal with deletion calculation is going to be this one. And it could be one of these four, actually. One of these four. Which could just be one function call, which is basically I can either, so there's the without deletion, there's the applying the deletion, and I can either take x as it is and not apply any deletion. I could take x without applying a deletion and the previous value, right? Whatever I got, so that with deletion up to that point plus x. Or I could apply the deletion and have a 0 at this point and take the previous sequence. Or I could apply the deletion directly, which should be 0, and take that spot, right? And really, it's only worth applying the deletion if this is a negative number. Obviously, this will be just negative otherwise. Or this will just be 0 anyway, so it's not really, but I could just start at 0 with that deleted if I wanted to. So yeah, something like this. It's a little bit involved, actually, a little more complicated than I thought it was. Oh no, uh-oh. Whoa. Uh-oh. 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 Okay. Huh? Well, that's confusing. Oh, okay. Never mind. This needs to go here. Never mind. What is going on? All right. A little more complicated than I thought. Yeah, there's some subtleties there. It's not that easy to follow, I think. Yeah, I gotta get it right. Okay, anyway, so let me generate some test cases. I think I'll spend a little bit of time generating test cases because it's definitely not obvious that this is correct. Pretty sure it's correct, but it's definitely one of those things that are like, it could be a little more complicated. All right, so let me do it this way. So I want a script. I want date plus %s %n, get line seed, srand seed, and then just print rand, right? Okay, now I'm gonna have some constant k. It's gonna be, let's do 100. Let's not do 100,000. It's maybe a little bit much. C is gonna be the number is gonna be from, we'll do C1 is negative 10,000, and C2, the range is gonna be 1,001. But I add the C1. I have to remember not to use commas in awk, which I tend not to remember to do that. And then I'm going to say 4, so I'm going to say x is going to be the output, the result. Say for I is 0, I is less than n. I should calculate n. N is going to be k rand times rand plus 1, so k is at least size 1. I is less than n, increment I, run a routine, eventually print x with opening and closing brackets. This is going to be x if I is greater than 0, x equals x and a comma. I think we put the comma first, and then I'm going to write a new value, which is going to be int of c1 plus c2 times rand. Right? And those two things will happen for the for loop. And I did that wrong. All the way around. Not always so obvious. Okay, very good. So let's do that 8 times for j in sequence 1 to 8. Do awk done. Right, there we go. Okay. So that's pretty good. Let's go ahead and let's try a few of these test cases. Generate some test cases and try them. Do another one. Wrong. Oh no. Oh, they're all wrong. Oh, that's rough. Oh, that's brutal. Ouch. Let's get some smaller ones. Let's try to figure out what I did wrong. Okay, so the logic was not right. I don't know. So I thought it was, but okay. I didn't prove it. It's something about it was like, I don't know, something's not quite right. Let's do, I wasn't too sure. So it's good that I tested it. Let's do like 5 elements, and let's do maybe smaller elements. Let's do like 10 and, oh, you know what, actually, I know it's wrong. Actually, no, I was okay. No, hold on. Take all that back. No, I did have the right idea. I know it's wrong. It's a good thing I tested it though. This just by accident. I wrote my script wrong, but I caught a test case that's, no, I had the right idea. This is supposed to be 20,001. That's what's wrong. But my handling of that edge case was incorrect. That was kind of subtle. So what happened is that I generated all negative test cases, and I didn't realize that I wanted, if they were all negative, I wanted the least negative number, not the min element, the max element, which was, that was a mistake on my part. Now it's all right. Gee, okay, well that's confusing. Yeah, okay, I do have the right idea. I'm okay, we're fine. Just, I don't know, man, what to say. Okay, I do, well, I'm not perfect, right? Sometimes I make small errors here and there. I have to catch. That's a very small error from max element instead of min element. All right, let's try more elements and make them closer together, tighter. Do 5 and 11. More elements close together. I'll do this like 2 more times. And I'll do one more. I'll do one more time this way, and then I want to make them like weighted towards negative numbers, and then weight them towards positive numbers. Oops. So weight them more on negative numbers. Just make it more negative. The range. Okay, so most of the time it's negative. More of the time it's going to be negative. Okay, it's looking pretty encouraging at this point. I think I got it. Yeah, it's weird kind of way of thinking about it, but it's, like I said, it's sort of a dynamic programming type of a thing. Let me see. Was that it? Is that all I need to do? So let me do it with the chat. How am I doing on time? And no in the chat. No chat. Okay. 30 minutes now. Let me see if there's anything else I could test. Oh yeah, if I weighted it towards positive numbers. Yeah. So I weighted it more heavily towards positive numbers, what would happen? That's another question. I think that'll be the last test. So I think I got it. Let me not call it too early. Okay, I'm gonna go for it. Oh, got it. Sweet. All right. So, hey, pretty good. 97%, not bad. So, if I'm going to submit it 5 more times, hopefully it made sense, the explanation. If you like the stream, give it a like and subscribe for more. I'm going to submit it 5 more times, and then I'm going to look to stop the stream here and maybe take a minute or two break. And then restart the stream on another question. I think we'll do it that way. I think this could be faster, by the way. I don't think this is like the absolute optimal way to do it. It's a reasonable way to do it. I mean, this is linear time, and no extra memory too. It's linear time, constant memory. Does an extra pass. So there are some I possibly could do this without doing an extra pass. It's kind of tricky to do this, like not apply the deletion. I'm not sure exactly. I think maybe I could use an if statement where the deletion only applies if it's a negative number. It's only considered if it's a negative number. Otherwise, it's not considered at all. In which case, yeah, I guess I could just have the deletion be, if it's negative, then it's set to 0. Otherwise, it's set to like an infinitely negative number, something like that. Like I could finagle with this a little bit and then not have to have the extra routine here. But I think overall, it's reasonable. So, okay. All right. Thank you for watching. Have a good rest of your day. If you like the video, give it a like and subscribe for more. I'm going to take a few minutes, I think. I don't know if I'm going to immediately start another one. I might, but